Does anybody remember what greatest common factor is or what it means? Perfect. So like if I think about greatest common factor, like maybe if I picked like the numbers 12, 20, and 24, they share factors of 2 and 4. Factors are numbers that multiply to give you those numbers. And if they share a 2 and they share a 4, the greatest common factor between those two is a 4. Correct. So there are various ways that we're going to go over greatest common factor. We're going to go over ways on here today, and then we'll go over another way. The other way that I do prefer, it's actually using what we call prime factorization. That's not going to be done today, but I do want you to understand that there is more than one way to do this. So when we're talking about, there's different ways that, for example, here you can use a T-chart. So when you use a T-chart, what you're doing is you're trying to find the product of two numbers by listing the factors. So you're listing factors on each side. So the two numbers that multiply to get, for example, if you got 4, you would list the factors as 1, 4, 2, 2. Those are the factors. So you have to list all pairs of factors. The first pair is always 1 and the product. So it says here, try 2, 3, and 4. So for example, the product or the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. The factors of 4 are 1 and 4 and 2 times 2. Remember, we did divisibility rules. You can utilize those divisibility rules as well to find all factors. That does help. All right, so like I said, you can use a T-chart to find the greatest common factors. And so you use a T-chart to list the factors. For example, we just went over a second ago 4. And 4, if you recall, was 1 times 4 and 2 times 2. These are the factors of 4. A common factor is a number, that is a factor of 2 or more numbers. So for example, here you notice that it says 2 times 3 is 6, 2 times 2 is equal to 4. So you should be able to recognize by looking at this that they share a common factor. Their common factor here being 2. So something that is recognized or something that is talked about is the fact that, you know, if you continue like to look for factors, you should actually technically go up to 4. You should continue to go through it, like 1 and 4, then 2 and 2, and then essentially you would try 3. 3 does not work, right? Because 3 doesn't go into 4. And then 4 does work, but because we already used 4 on this side, it's considered like a twin in a sense. So because it was already used, you would just stop. Because essentially when you're looking for the factors, you might only think of a certain amount, but they do sometimes go beyond that amount. So I know that if I think about factors, for example, of like 12, instantly I might say 1 and 12 and then 2 and 6. But then what if I forget about 3 and 4? Like you should continue going down throughout the numbers. Like you don't want to just stop and assume that you're done with finding all factor pairs. All right, so continuing on, something that I just finished mentioning, and it is said over here on this side as well. If a number is already listed or it is a twin, stop. Because if it's a twin, that means you already found it. That's the example that I gave over here with the product of 4. 1 and 4, 2 and 2, 3 didn't work, and then when I got to 4 was a twin. I already used it, so I know I can stop. There's nothing beyond that number. So let's go ahead and work together to find the GCF for these pairs. So the first two pairs that I see here are 36 and 48. And if I'm working with the pairs like I should, I always start with 1 and the product. So I have 1 times 36. I have 2 and 18. I have 3 and 12. I have 4 and 9. 5 doesn't work. 6.
Yeah.
6 goes into it. What about 7?
No.
What about 8?
No.
What about 8?
Yeah.
No. What about 9?
Yes.
Yes, but we already used it right here with the 4, so it's a twin, so we stop. We don't have to do any more. That's the furthest we can go. So these are our pairs here. So for 36, I have all of these as the listed factors. These are the ones that multiply to give you 36. Then we have 48. We have 1 and 48, 2 and 24, 3 and 16, 4 and 12. What about 5?
No.
Why not? Right, it doesn't end in a 5 or a 0. Okay. What about 6?
Yeah. 6 and 8.
6 and 8. What about 7?
No.
About 9?
Yes. No.
No.
Mm-mm. 10?
No.
Nope. 11?
No.
12?
Yes.
Yes, but we already have it, so we stop. So we know we found the twin, so we can stop. We actually probably, I didn't even think about it, should have stopped at 8, right?
Indeed.
Because 8 was the first time a twin appeared, but I kept going, sorry. I said 6, then I said 7, and then I skipped 8. I went right to 9. None of you guys caught that. That's okay. Happens to the best of us. So now, there's one way of listing it. So you can either list the common factors this way in a T-chart. Another way that students are taught, I think they call it like the rainbow method, where they will write 1 and 36, and it's called the rainbow method because they meet like this, and then 2 and 18, and then 3 and 12. I'm going to run out of room. 4 and 9. I'm going to make it work. Oh, and then I just only need 6 one time. Why do I only need it one time?
Because Ray has it.
Yeah, it's a pair. So actually I didn't really run out of room, but I was trying to make it work. All right. So I don't have to write this as the rainbows. Like I don't need to show this because I already have the list here. So I'm just going to rewrite these factors too. And I'm always going to write it from the smallest number leading up to the largest number. So this would be 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. Looking at my list, I see that they share a factor of 1. They share a factor of 2. They share a factor of 3, 4, 6, 12, and no more. That's it. So their common factors, which we just circled, are 1, 2, 3, 4, 6, and 12. These are the common factors. What is their greatest common factor? 12. 12 is their greatest common factor. And like I said, there is other ways to do this. There's one that I like to use called prime factorization. The reason why I like using prime factorization, because prime factorization can be used to find your GCF and your LCM. So if one method could be used for both, that's the reason why I prefer that method. All right, moving on, we have the next set of pairs, 21 and 35. So for 21, we know 1 and 21. 2? Nope. 3?
Yeah.
Yep. 4?
No.
5?
No.
6?
No.
7?
No. Yes.
Yes, so we stop because we already are there. We've found the most pairs that they share, 1 and 21 and 3 and 7. 35 is next, 1 and
35.
just 2.
No.
Why not?
Is
It's
that
not
5?
even.
Not an even number. Perfect. 3.
Yes. No.
Nope, no 3. 4.
No.
Nope. 5.
Yes.
5 and
7.
6.
6.
Nope, 6 doesn't work. Moving on. 7. Yes, we know it works, so we stop because that is the twin. We already have the numbers, so I don't need to write this as like a little rainbow like I did before tree. I know it's 1, 3, 7, 21, 1, 5, 7, 35. They share a 1. They share a 7. So their common factors are 1 and 7, and therefore their GCF is 7. Another example at the bottom, so let's go ahead and move to the bottom. It wants us to find the GCF of 4 and 8. We've already done 4. If you recall up here, we did 4. We know that the factors for 4 are 1, 4, and 2, 2. We checked the other ones, and then essentially we stopped like we did before. So I know it is 1 and 4 as well as 2 and 2. For 8, I have 1 and 8, 2 and 4. Does 3 work? Nope. And if I check 4, I've already used 4, so I stop because that is its twin. It's exciting news.
What would happen if I put 2, then 1? That's not how it works.
Yeah, you should work from least to greatest always when you're working on stuff, especially with the math stuff.
It's like reading like right to left.
But we don't read right to left. All right, 1, 2, 4. I didn't write 2 twice because it doesn't need to be written twice. If it exists as a factor, we know it does. And then 1, 2, 4, and 8. They share
4.
a 1, a 2, and a 4. So their common factors are 1, 2, and 4. And that means that their GCF is 4. So remember, when you cut this and then paste this into the notebook, you want to leave a little bit of room below it so you can put some examples. So I'm going to go ahead and write those examples down, and then we're going to work through the problems together. Okay, so here are the following examples. If you like to copy these down, I suggest to pause the video here, copy this down, because these are examples going into your notebook. I will stick with the T-chart for the first one. So if I look at the number 30, T-chart, because it's a T. 30 is 1 and 30, 2 and 15, 3 and 10. Does 4 work?
No.
5 and
6.
does 7 work?
Well, we can't do 5.
Why can't we do 5?
Because the others, oh wait, never mind.
Yeah, so 5 and 6, does 7 work? No, oh, sorry, does 6 work? After 5, we have 6. 6
No.
works, but we found it already, so we move on. Gosh, I'm getting sidetracked. All right, 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Does 5 work? Does 6 work? Yes, but that's a twin we've already found, right? So now if you look at your numbers, they share 1, they share 2,
6.
they share 3, they share 6, and then that's the most that they share, so therefore the GCF is 6. So we can do that method. And then you can also do the method where we list the pairs like the following, the kind of that rainbow method. 20 is 1 and 20. 2 and 10. 3 does not work. 4 does work. And because 4 and 5 would be the next thing we would check, we know we stop there. 12. 1 and 12. 2 and 6. 3 and 4. And we know we would stop there because the next number to check after 3 is 4. 32. 1 and 32. 2 and 16. Does 3 work?
No.
No. Does 4?
Yes.
4 and 8. Does 5?
No.
Does 6?
Yes. No. No.
No. Does 7?
No.
No. Does 8?
Yeah, but you already did that.
Yep, already did that. So, oopsie. Love this. Yeah, so I'm done there, and I could pull these closer if I really wanted to. I don't need to. I see they share a 1, a 2, a 4, and that looks like it's it, right? So their GCF is 4. Perfect. So these go into your notebook. Your homework tonight is the math space. It is the math space. Please make sure that you are completing the math space and actually doing it legitimately. I give you your grade also based on the amount of time you're on there. I know how long they take. It gives me a timestamp of how long they take. And I know that when I see times that are not legitimate, there's other ways that you're probably completing this. So make sure that you're doing these honestly. Thank you.